This experiment was with a zinc atom, projected atom. It was ionized. You can tell that because you can't see the rings or the face of the atom. You can only see the protons, the charged particles that are forming the dome over it. The black dots you're seeing, those are electrons. The white dots that appear every so often are positrons. They are fragments of space that are either carrying a charge or have had been carrying a charge. That's what an electron is. It's something that had a charge, but then that charge was removed and it no longer has a charge. That's what negative is. Okay? The positrons are orbiting. They're just picking up charge and dropping it off just like the electrons are as they orbit through the atom. The reason the electrons, this hung me up for quite a while, but the electrons are just like when the energy was initially made by mass squared. The electrons are what occurs when protons occupy or try to occupy the same space as each other. So when mass tries to occupy the same space as each other, it turns into energy. So when protons try to do it, it ejects one of them and creates a negative and a positive, I guess. As it orbits through, it changes both. So this test was to see if any of the other spectrums of light, the different wavelengths, were better suited for observing the electrons and positrons in this particular ionized state of zinc. Please excuse me, I'm getting a cold. As you can see, the yellow and white lights work better for observing the electrons. They make them show up better, they make the positrons show up better. Some of the blue and green also made the electrons and positrons visible. There you see them right there. This is another experiment. This is just the observations of a projected atom from a DC motor rotator. Here you see it zoomed in. I'll show you the structure of an atom. This is the face, what I call the face. In the center you see the core. Around the core, that area where it doesn't look like anything is, it's kind of darker, but it's not black. It's not where light's being absorbed, it's just the lack of anything else being there. That's where the space inside the atom is connected to the space on this side of the atom. Okay, so the space being compressed inside the atom connects to the space outside the atom right there. Now when it becomes ionized, a dome forms over this, and it narrows that. It probably stays about the same, I suppose. But it would compress space a lot more. And there's a close-up of the core. Think of a compressed sphere, okay? If you stuck your finger from the bottom of the sphere in the South Pole and pushed that South Pole up through the North Pole so that the inside of the sphere's southern pole is sticking out, that would be the inside of the sphere's southern pole right there. And the rings are changes in direction of the flow of protons through the atom. So every ring you see is where the protons are flowing up. They're making the turn and then flowing back down. And they do this till they get to the end where they make the final pass and form a dome where they're finally pulled back into the core of the atom. That's what's causing all that movement right there in the center, is the flow of protons back into the atom. This is one of the better ones. It's really great detail. I mean, you really couldn't ask for a much clearer shot. Again, these are like highlight reels. I have so much data that I could be posting, but I don't want to bog down everything with all my stuff. I mean, I'll leave it open access on like cloud server or something for everybody to access if they want. So E equals m squared. Turns out Einstein was very close.